This is David Blair along with Josue Paulino and Jordan Todd, and we are presenting a plan to improve the assembly process of Meritor's automatic brake slack adjuster. The device, shown here, automatically adjusts the slack out of the drum brakes for commercial trucks. The commercial product involves an assembly process followed by a grease fitting. However, for this project, we focused on improving only the first stage of the assembly. This involves a rod, roller, piston, snap ring, and actuator. By observing the current assembly process as well as information supplied by the company, our team found several issues. The time it took to successfully train a new operator was excessive. The cycle time of the production was largely dependent on which operator was working. There were high levels of fatigue and poor ergonomics for a person working 8 hours a day, and that the workspace was cluttered with boxes of different parts. Our solution is to make the process semi-automatic by dividing the assembly steps into positions on an indexing wheel, much like the process used to manufacture shotgun shells. Also, to make the piston rod a subassembly and have these stored in magazines. The process would be completed by two kinds of station. The first is the assembly of the piston, rod, and roller, where the completed subassembly is stored in magazines. The second station is the revolving wheel, where the operator takes the piston rod assembly and a snap ring and places it into the carrier slot on the wheel. This is a concept sketch of a U-shaped magazine in which the finished subassembly could be stored, and then transferred to the second station for final assembly. This is a linearized view of the revolving wheel. The wheel is divided into 6 positions that result in the output of the finished assembly. First, the actuator is fed from a hopper or drum feeder into the initial slot on the revolving wheel. During this time, the guide collar is held above the insertion point by a cam towards the inside of the wheel. The guide collar then lowers down as the station indexes forward, securing the actuator. The third position is where the operator is engaged. The operator removes a piston rod assembly from the magazine, the snap ring from a box, and places them in the actuator. The next position has a pneumatic press that secures the snap ring within the housing. This press is activated when the operator indexes the machine forward using a 2-hand safety switch after inserting the piston rod assembly. The guide collar is then raised back above the part by following the cam path. Finally, the part moves over a hole in the wheel support plate and drops into a finished goods bin. At this point, the bin can be taken to the grease fitting station. This improvement will require an initial investment. However, there are several benefits for the company in the long run. By reducing the amount of operations required in the assembly, the time to train operators will drastically reduce. Because the process is more simple to perform, this allows more flexibility within the workforce to cover for cases like vacation, illness, and unexpected absences. By making the system semi-automatic, this reduces the variability in cycle time among operators, allowing management to better predict production numbers. The number of parts handled and operations performed per product is reduced, leading to greatly reduced fatigue in the operator throughout the day. This streamlined process also reduces the amount of parts bins in the workspace, reducing clutter and potential for mixed components. Overall, this improvement will enable Meritor to increase stability in the production of the device while also reducing operator fatigue and presents a more orderly workspace.